Welcome to Crosstalk Solutions. My name's Chris, and today we're going to be setting up a Raspberry Pi surveillance monitor. Now, I have done this project before, but I wasn't entirely happy with the previous version. So we're going to call this version 2. Version 2 is a little bit bigger, and I think it's a little bit more of a solid solution than the previous version. So what was my criteria for a surveillance monitor? First and foremost, I wanted to be able to see 4 cameras on the screen comfortably, whereas the last version I only had a single camera, and it was displayed through the Unify video software and put into full screen mode. So it was just a little bit flaky. It sort of kept timing out every once in a while. With this version, I'm using RTSP streams, which is going to work with Unify video. It's going to work with Unify Protect. It's going to work with any camera system that supports RTSP video feeds. I also wanted as few cables as possible, so I have this down to 2 cables, one power cable for the monitor itself, and then a single network cable that also provides PoE power to the Raspberry Pi using a Raspberry Pi hat. Now, you could actually get away with 1 power to the monitor and 1 power to the Raspberry Pi. If you're using the Raspberry Pi version 3 Model B+, it has built-in Wi-Fi, and therefore you wouldn't need a network cable. You would just need to supply power only. And furthermore, I was reading about this monitor, and it has 2 micro USB ports on the top of the monitor. One of the micro USB ports is for power in. The other micro USB port is undefined, but there were people that were speculating that it could possibly be used as a power pass-through to then also power up the Raspberry Pi, which I have a cable on order, a micro USB to micro USB cable on order. I'm going to test that out, but I just don't have it today. So for now, I've gotten it down to 2 cables, and that's actually pretty good. The third thing I wanted was to be able to have this system automatically start displaying the cameras upon boot up. That way, if there was ever a power outage or something like that where the Raspberry Pi was shut down, or if you just wanted to move it somewhere else, you can just plug it in and it will come up with the cameras in the configuration that you originally set up. Reason being is if you have to go in and figure it out and it's been months and all of a sudden your cameras aren't working, you got to go log in and say, well, what was the password to that Raspberry Pi? Oh yeah, what was the IP address? How did I set up those cameras again? What was the configuration file? And it would just be a lot of work to try to sort of dig back into the project and figure it out if you haven't visited the project in quite a while. So booting up directly to this display of the cameras was 100% necessary for my project criteria. So the display screen that I'm using is an 8-inch IPS display screen from Ymaxit. I will put the link to all of the equipment that I'm using for this build down in the description below. And this is a really nice looking display screen. This has 1200 by 800 resolution, and the build quality is about what you would expect for a monitor that costs $75. You know, an 8-inch IPS display that costs $75. This is just acrylic sheets that have been cut out into the shape to basically hold the smaller 8-inch screen in place. So the bevel's a little bit large, but it doesn't look too bad. And it actually comes with the paper protectant that comes with acrylic sheets still attached to the acrylic sheet. So you had to kind of unscrew all of these screws in order to peel off that paper backing that it comes with. I still have it on the back, which I just kind of left alone. There was also a piece of plastic that was protecting the whole screen, and it had a little pull tab so that you could pull that off of there, but that actually, the pull tab just came right off and it didn't pull up the plastic that's actually on top of the screen. So while I had the screws out and while I had sort of taken the acrylic pieces apart, if you're going to be doing this same project, don't forget to peel off that piece of plastic while you're in there, because you don't want to be, you know, having to unscrew this whole thing more than once. Now this setup comes with these little these little feet here that are used to just prop it up at this angle. However, of course, I'm sure you could figure out a way to mount this on a wall or something like that if you wanted to, but it does not actually have any wall mounting hardware included with the display screen. So yeah, 75 bucks from Amazon for this display. The Raspberry Pi board attaches directly to the back of the display, so you don't have to worry about having a separate Raspberry Pi somewhere else, though you could absolutely do this same project with a Raspberry Pi somewhere else, as long as you have a long enough HDMI cable to go from the Raspberry Pi over to the display screen. Another thing is that everything that I'm doing here does not require this display screen. All right, you could use any screen that you want, a regular computer monitor, a big television screen, whatever you want to do, as long as it can receive an HDMI input. you can do this same project with your own screen. This is just the one that I chose because I wanted a nice compact screen to sit right on my desk. So setup of the display screen is actually pretty simple. What you get in the box is the display screen itself, a little HDMI bridge that basically folds over like so and connects the HDMI of the display screen to the HDMI of the Raspberry Pi. And then you get a micro USB power cable. Although the system was flickering a little bit when I was using this micro USB power cable, the monitor takes 5 volts, 2 amps, and so I ended up using an actual power brick to power the monitor instead of running it off of USB. It seems to be a little bit more solid that way. And then of course you get a couple of feet or stands that you can mount to the back of the system to keep it upright in this position. Okay, so with all that being said, let's go ahead and get started with this actual project, and we're gonna move over to my computer and get the whole thing set up from scratch. Okay, so I've moved my surveillance monitor over here right next to me so you guys can see it as it displays the camera and as we get going. And the first thing we're gonna do is we're gonna pull the SD card out of this system and then reformat it and start completely from scratch as if I was doing this for the first time. So here I am logged into the server. I'm gonna shut it down gracefully with a sudo shutdown -h now. And now we can see that the server is going down and it should just take a second. There we go, it is off. Okay, pull the SD card out. Now I'm using a SanDisk Ultra 8 GB micro SD card. That's a class 10. You don't need a ton of space for this, so don't go blowing your money on like a 64 gig SD card or micro SD card. You just don't need it. This 8 gig card works perfectly fine. All right, putting that in my card reader, and it comes up as drive G. So first I'm going to format the micro SD card. I do that using a program called SD Card Formatter. It is free to download and use. And you just want to make sure that you are selecting the correct card. In my case, I know the drive letter is G. I'm going to delete the volume label. It'll recreate it anyways, and I'm just going to say format and yes. And there we go. The next thing we want to do is to add the Raspberry Pi image or the Raspbian OS image that we're going to use. And in our case, we're going to use the Raspbian Stretch Lite image. This is a really bare bones Raspberry Pi operating system. It has no graphical user interface whatsoever because we just don't need one for this install. So we don't need extra processes running that are going to take up CPU and RAM on the Raspberry Pi. So to get that software, we're going to go to raspberrypi.org and we're going to click on Downloads. You can also use the Noobs out of the box software install. However, if you're going to use Noobs, when it boots up and gives you the menu item of the different operating systems to choose from, make sure you choose the light version of Raspbian, again with no graphical user interface. So we're going to click on Raspbian in our case though, and the one we want here is this one here, Raspbian Stretch Lite. So you can download a zip or download a torrent. Once you have it downloaded, you're going to want to extract that to your hard drive, and then we're going to use a program called Win32 Disk Imager to place that image onto our micro SD card. So here we go. This is Win32 Disk Imager. The first thing I always do is make sure I have the correct device selected, because if you image the wrong drive, like if you image your backup drive where you have all your family photos or something like that, it is gone. So you want to double and triple check that you have the correct drive or the correct device selected. And then here we go. We're going to browse for our image file. Okay, and I have it selected. In our case, it's the 2018 November 13th version of Raspbian Stretch Lite, and we're just going to say write that to our G drive. Okay, write successful means that we have successfully written that image to our drive, so we can close out Win32 Disk Imager. The next step is to take the micro SD card and put it into the Raspberry Pi and boot it up. However, there's a little tip here that we're going to give you, and that is to create a file called ssh.txt in the root of the micro SD card. And the reason that we do that is because it tells Raspbian when it boots up to just automatically enable SSH so that we can SSH right in and we don't have to, mess around with hooking up a keyboard and mouse or hooking it up to a monitor and running an if config to find the IP address. that sort of stuff. So SSH is going to be enabled by default, and then you can look up the IP address either in your DHCP lease table, or I just happen to already know the IP address of this one since I've been working with this same Raspberry Pi for a couple days now. So let's bring up the root of the Raspberry Pi. It is the G drive, and here you can see the files that were copied over. We're just going to say new text document, and we're going to call it ssh.text. That's all you need to do. Close that out, pull the microSD card out of your card reader, and then pop it into the Raspberry Pi. All right, there we go. Now, in my case, again, I have this PoE hat, so I am able to just plug in Ethernet and get the power to the Raspberry Pi through the power over Ethernet switch that I have here. But if you don't have PoE, you're going to want to plug in a network cable as well as power to the Raspberry Pi and power to the monitor in order to do the initial setup. There we go. We see the Raspberry Pi logo coming up. Resized root file system rebooting in 5 seconds. So again, it does a couple of maintenance things right off the bat, but eventually it'll come up with our login prompt. Okay, there we go. We have the login prompt. You can also see your IP address right here. It says my IP address is 192.168.200.206. So that is what we're going to connect to with PuTTY. The default login and password is Pi for the user, and then the password is Raspberry, R-A-S-P-B-E-R-R-Y. Okay, so we are now logged in. The first thing that we want to do here is run sudo raspi-config. This is pretty much the first step for any Raspberry Pi. It just allows you to set up some of the system settings for the device. The first thing we're going to do is change our user password to something stronger than Raspberry. So enter it once and confirm it. And that part is done. The next thing we want to do is come down here to our boot options, and we're going to say wait for network at boot, and we're going to enable that because since this is going to be a network attached device, we always want to make sure the network's there, or this thing is pretty useless anyways because we're viewing these cameras from RTSP streams across the network. So if the network hasn't started, there's really no reason to finish the rest of the booting until we actually have network connectivity. Otherwise, it's just going to boot up, it's going to try to start that display service, and then there's no network, and it's just going to sort of mess everything up. So wait until network's there to finish booting up the Raspberry Pi. Then we want to go to localization options. This is going to allow us to set our time zone. In my case, I am America, Los Angeles. And then we can come down here to interfacing options, and we want to turn SSH on. There we go. And then finally, two things we want to do in advanced options. So the first thing we want to do is expand the file system. This is going to allow the Raspbian to take full use of the SD card, the micro SD card that we put in. And then the second thing we want to do is change our memory split. So by default, we're only allocating 64 megabytes of RAM to the graphics card of the Raspberry Pi. We're going to bump that all the way up to 256 megabytes, which is the maximum that you can allocate to the GPU of the Raspberry Pi, and we're going to hit OK. Once all that's done, we're going to say finish, and it will reboot once again. Okay, once it's rebooted, we're going to reconnect to that same session. And now it's time to update the Raspberry Pi. So we're going to say sudo apt-get update. This is going to refresh all of the software repositories so that the system knows the latest and greatest versions of all the software that's installed. And then we're going to go ahead and run those updates with sudo apt-get upgrade-y, and then we're going to tack on a second command because we're going to want to reboot after we run all these updates. So we're going to say and to run a secondary command after the first one finishes. We're going to say sudo reboot. All right, hit enter, and this update and reboot process is going to take probably about 10 minutes, so we'll come back after that's done. Okay, so we're all updated, and now the next step here is probably the most difficult part of this whole project, and that is to install display cameras and then actually configure the config file in order to get the cameras to display properly on the screen. And it's not really that it's that difficult, but there's a little bit of math involved in terms of figuring out the size of your screen and basically where to position each camera given the amount of pixels that you have available. By the way, I should mention that I pulled all of this information from a blog called the Self-Hosted Home Blog. So if you want more written instructions for basically the exact same thing that I'm doing here, I will have a link down below. I always want to give credit where credit is due. This was a very nicely written blog post and basically laid everything out, and it works really well. Okay, so the next thing we're going to do here is install a little program called Display Cameras. And in order to do that, we want to first go wget, we want to download it, wget https://github.com/anonymous/display cameras/archive/0.8.3.3.zip. Now, why is it an archive? I don't know. This is just the version that was used in the blog post, so it's the version that I'm using, and it works just fine. Okay, downloaded. Now we want to say unzip, and then the name of that same file, 0.8.3.3.zip. And now it's put that information into a folder, so we're going to say cd display cameras 0.8.3.3. And if we look in here, the first thing you'll notice is install.sh. So this is the application that we're going to run to install display cameras onto our system. And it is not currently executable. If you look at the properties, we have no X's in here, so you cannot run this as a program currently. So we're going to first change that. We're going to say chmod +X, add the executable flag to install.sh. Now if we say ls-la again, it's now green and we have our executable flag. The other thing you might want to take a look at is the example layouts directory. So the file that we're going to ultimately modify is this layout.conf.default. But if you go into example layouts, you'll see example layouts, so you don't have to do the math on the pixel size like we're going to do if your layout or if your display equals any of these resolutions, 1280 by 1028, 1280 by 720, etc. Our resolution is 1280 by 800, so they don't have a pre-populated layout.conf file for us. We're going to have to figure it out, but that's okay. By the way, I think I said the display screen was 1200 by 800 earlier in this video. It's 1280 by 800 is the resolution. And let's go ahead and install display cameras by saying sudo /install.sh. There we go, and the install of display cameras takes about a minute or so, and once it's done, there will be 2 questions that it asks us. You're basically going to take the defaults on both of those and just hit enter, enter, but I'll go over them once we're at that stage. Okay, there we go. So now we have the first question is enter a custom GPU split if desired, or press enter to use the recommended split. Now we already did this earlier when we went into the advanced options in the Raspberry Pi config, so we're just going to hit enter here. And then finally, do you want to see the README? We don't need to see the README, though if you're interested, I would suggest certainly taking a look through it. Okay, so that is now done, and now it's time to actually set up our cameras. So the first thing that you need when you're setting up your cameras is an RTSP stream. Now, normally I work with Ubiquiti cameras. That's going to be Unify Video or Unify Protect. My cameras are currently on Unify Protect. So let's bring over Unify Protect and we'll look at how you set up the RTSP portion of Protect. Okay, here I am in Protect. Here are my 4 cameras. I'm going to click on this at G3 with IR Extender, and then if we click on the Manage, you can see the RTSP section down here. Now I've chosen medium quality, which is 1024 by 576. That's plenty big enough for the display screen that I'm using, but if you're putting this on a big TV or something like that, you might want to go for the high quality stream, which is 1920 by 1080. Of course, the bigger the RTSP, or the higher quality of your RTSP stream, the more bandwidth that is used up as that video is flowing around your network. Okay, so all you want to do is basically just enable that RTSP stream, and that gives you a URL. So now we can copy that URL. Note also that if you're doing this from the outside world, there is a port here, port 7447, so you're going to want to make sure that that is accessible to you either through VPN or through a port forward in the firewall or something like that. If you want to test if the RTSP stream is working, you can use the VLC client for that. I'm going to copy this, and then I'm going to bring up VLC. Here we go. This is VLC Media Player. Most of you are probably familiar with this, but if not, it's a free download. You can just download it. And if you do Media, Open Network Stream, you can just paste in the URL, starting with RTSP:// the exact stuff that you copied right out of Protect or Unify Video, and then just click Play. And there we go. We can see that my RTSP stream is working just fine. Okay, close out VLC. And once you turn on RTSP for all of your cameras, it's just the same process. Just flip the switch basically, and you're good to go. We're going to want to copy these and then paste them into this config file in just a second. So let's go back over to SSH. All right, so back in SSH, the next thing that we want to do is modify some config files here. So if we go to cd/etc/display cameras, and then if we look in this folder, we're going to see two files, displaycameras.conf and then layout.conf.default. The more important one here is layout.conf.default. However, we're going to take a look at both of these files in just a second. For now, though, let's do sudo nano-w layout.conf.default. Now, this file determines how cameras are displayed on the screen, and you can have 4 cameras displayed and then another 4 cameras displayed and then sort of swap between those two views if you want. However, since I only have 4 cameras total, we're only going to be working with a single screen that's going to be static. It's not going to be switching between different cameras or anything like that. The first thing we want are our window names. Now I'm just going to take the defaults here because it's fine. Upper left, upper right, lower left, lower right. And then, of course, keep in mind there's off-screen 2, off-screen 3, etc. if you have more than just the 4 original cameras that I do. All right, now if we scroll down a little bit here, we're going to go to Window Positions. So here's our upper left. Now, the default file here is based off of a screen that looks like it is 1020 by, or 1920 by 1080. Right, so that's like basically regular high definition. In our case, though, we are 1280 by 800, so we need to adjust things a little bit. Now, how do you do that? How do you figure it out? Here it is, basically. I have this little mock-up in Photoshop. This is my screen. We can see it's 1280 by 800 pixels, meaning that this is the x-axis going from left to right. And then we have the y-axis going from the top to the bottom. So up here in the upper left-hand corner, that is 0, 0. And then if we take all the way across the x-axis, we are at 1279, 0. And then if we go all the way diagonally to the bottom right here, that is 1279, 799. And those are pixels, right? That's the pixel count. So camera 1 is going to be laid out from 0, 0 in the upper left-hand corner, down to 639, 399 in the lower right-hand corner. Camera 2 is going to be at X640, Y0 in the upper left-hand, and then down in the lower right-hand, 1279, 399, and so so on and so forth. So if you do this same sort of thing, you can pretty easily figure out exactly which pixel counts you need to enter into this config file. So these are the ones that we're going to use. Let's go ahead and bring back SSH. So the upper left runs from 0, 0 to 639, 399. And then we do the next one, upper right. Upper right is 640, 0, 1279, 399. Again, we go back here, 640, 0, 1279, 399. Let's do camera 3 and 4 as well. Okay, there we go. So I've got all of those in there. For the off-screen ones, you don't need to change those at all. If you're not using them, don't worry about it. However, if you are using the off-screen ones, just imagine one monitor, count up all those pixels, and then add another monitor off to the side, to the right of the first monitor, and just use those pixel counts instead. Now, we get down to our camera names. So for camera names, like I said, I only have 4 here, and my cameras are driveway, office, deck, and flex. The flex is just my flex camera, which I kind of move around different places wherever I need it. And then we've got our camera feed. So this is where we're going to add in our RTSP streams. And notice that they have laid it out with the original names that it came with. So we're actually going to change that. We're going to say driveway, office, deck, flex. And then what we want to do here is get rid of these camera stream URLs. There's 4 of them. And this is where we're going to input the RTSP URL string for each of our 4 cameras. So let's start with the driveway. That is my G3 with IR extender. We're going to say manage. We're going to select this, copy it, go back to putty, and if you just right click, that is a paste. And then bring the cursor down to the next spot. Office is this dome camera right above me here. We're going to say dome, manage, copy the RTSP string, and right click to paste. And I'm going to repeat that same thing for the deck camera and the flex camera. Okay, there we go. So all of my RTSP strings are in, and that should be it. So let's go ahead and save this file. Control X, yes, enter. And now let's take a look at displaycameras.conf. Sudo nano-w displaycameras.conf. And in here we have some global options. You can sort of go through and read through these options. There's really not a lot of these that you're going to have to mess with. The default settings are typically fine. However, if you have multiple pages of cameras, so if you have 8 cameras and you're going to display 4 and then display the next 4 and sort of cycle back and forth between those sets of cameras, the only thing you might want to change is the last setting in this file, which is the rotate delay. So by default, it's every 5 seconds, but if you want it to be faster or slower than that, you can change it here. So if you say rotate delay equals 8, then it's going to switch that display every 8 seconds instead of every 5 seconds. All right. In our case, though, we're just going to leave this file default. We're going to say Control X, and we are out of it. All right, so here we go. It's time to fire up these cameras. You can see my display here. I'll try to pull it a little bit closer. And what we're going to do is just restart the display cameras service. And once that service restarts, it'll take all of our new configuration settings, and we should see cameras start to populate one by one on this screen. So let's go ahead and do that next. Sudo systemctl restart display cameras dot service. Enter. Now this takes a little while. It's going to take probably about 30 seconds to do it, depending on the number of cameras you have, because it's going out and it's grabbing those RTSP streams. We can see the first one already showed up, and then it's displaying them one by one. So there's driveway, office. Next we'll get this one over here. Boom, there's my deck. And then finally we'll get our last one right here, which is the flex camera. There we go. Okay, so all of that stuff is now up and running and operational. We now have a fully functional display screen or surveillance monitor with 4 cameras running RTSP. All right, last thing we need to check. What happens when we reboot this thing? It should reboot and come right back up with the same exact view. So let's go ahead and do that next. Okay, so we're going to say sudo reboot, enter, and there we can see the camera's turned off and we are rebooting. There we go. Camera 1, 2, 3, and 4. Okay, there we go. I didn't touch it, and all those cameras are back up and running. All right, so there you have it. There's the entire setup, and once you're all done, you should have a very similar setup to what I have here. And keep in mind that this is a pretty solid yet inexpensive solution to have a nice little monitoring station for looking at cameras and, you know, just keeping an eye on things. I kind of like having it so I can see, like, if the UPS guy shows up, I'll sort of notice, you know, motion out of the corner of my eye, and I'll be able to see that. The display screen quality is okay. It's actually pretty good for 75 bucks. It looks really nice, but the build quality, just being that it's encased in just these acrylic sheets that have been cut out, that's the part that's not the best build quality. The monitor itself looks really, really beautiful, and so I have no faults with the actual monitor. It's just the build quality of the surrounding components of the display screen. So you may have noticed also that I actually have 2 of these monitors. Now, the company that sent this to me, they reached out to me. They said, hey, we've got these monitors. Would you like to try them out? And I said, absolutely, because I happen to be in the market for a solution like this anyways. But I told them, listen, whenever I do reviews online, I want two of them, right? One of them that I can use for testing and setup purposes, and a second one that I can give away. However, the first one that I opened up and tried did not work. Now, on Amazon, there's only 5 reviews. They've got 4.5 stars out of those 5 reviews, so the working ones seem to be just fine, but unfortunately, I received one that was kind of DOA. When you plug in the power, the little LEDs on the back blink once, and there's just a little bit of a display that just pops onto the screen and then disappears, but it never shows the actual splash screen for the company that sent this to me, like the one that Works does. So I think there's just something wrong with this one, and if I had purchased it, I would be shipping it back or getting an RMA. But again, your mileage may vary. Hopefully this was just a fluke and the rest of them are totally fine, but I wanted to make sure that you guys got all the information, and that's also why I'm not going to be giving one away, because I ultimately needed 2 of them to get this video done. Okay, well, I hope you guys enjoyed this. What do you think about this solution? If you like it or don't like it, let me know down in the comments below. And yeah, I'd be curious to hear what you guys have set up for similar types of surveillance applications. Okay, so my name's Chris with Crosstalk Solutions, and thank you guys so much for watching.